Hello, algebra students. Today we are going to be learning about right triangle trig. Our goals for today is by the end of this lesson, you should be able to use right triangle trigonometry to evaluate trigonometric functions, solve right triangles, and use the concept of angles in standard position, reference angles, and coterminal angles to evaluate trigonometric functions. So let's get started. Trigonometry is simply the study of the relationships amongst the angles and sides of a right triangle. The first three trig functions you learned about when you were in geometry: sine, cosine, and tangent. You may or may not remember, but sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is opposite over adjacent. Now, these are all ratios or fractions. The other three trig functions that you may or may not have seen before are cosecant, secant, and cotangent. Cosecant is the ratio of hypotenuse over opposite. Secant is the ratio of hypotenuse over adjacent. And cotangent is the ratio of adjacent over opposite. There is a typo here. You guys probably want to fix that. This should say cotangent of theta equals adjacent over opposite. So sorry about that, guys. Now that we have all six ratios written down, you probably notice that there's a relationship amongst these trig functions. Sine, cosine, and tangent are reciprocals of cosecant, secant, and cotangent. So what does that mean? Cosecant is simply 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. This fact allows us to simply flip the fraction or write the reciprocal of the fraction once we found the first three. Now, where do these opposite, adjacent, and hypotenuse come from? Before we can decide that, we need to go ahead and draw in our right angle and our theta. This theta we use a lot in trigonometry, and all that simply refers to is the angle that we are referencing. So whenever you see this little circle with the line through it, it's a Greek letter, and all it means is an angle. So what's the opposite? Opposite is going to be across from the theta, so right over there. Adjacent is going to be next to, and hypotenuse is always the longest side, and it is across from the right angle. So there's your opposite, adjacent, and hypotenuse. And this SOHCAHTOA up here, this should look familiar. We use SOHCAHTOA to help us remember the first three trig functions from last year. And then once we have those three trig functions, we just simply list the reciprocals. So let's go ahead and get started. Problem number 1 here, I went ahead and drew in my right angle and theta, and I'm going to go ahead and label the sides with a 6, an 8, and a 10. So now that my sides are labeled, I can go ahead and list my first three trig functions. Sine of theta would be 6 over 10, opposite over hypotenuse. Cosine of theta, 8 over 10, or adjacent over hypotenuse. And tangent of theta is 6 over 8, or opposite over adjacent. Once we've listed these out, we need to make sure that we're all simplified, and we're not in this case. Every time you write a ratio, it always needs to be simplified. So 6/10 becomes 3/5, 8/10 becomes 4/5, and 6/8 becomes 3/4. Now that we have simplified fractions, we can go ahead and list out our reciprocal functions. As you may or may not remember, the reciprocals are these. Sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. And this first one's written in for us. Since sine is 3/5, the reciprocal of that is 5/3. Cosine is 4/5, therefore secant is that reciprocal, 5/4. And tangent, which was 3/4, therefore the reciprocal or cotangent is just 4/3. So hopefully that makes sense, and you're ready to try the next problem on your own. Problem number 2, go ahead and draw in your theta and label your triangles with the 7, 24, 25. Pause the video now and see if you can list out the 6 trig functions. So go ahead and pause now. So hopefully you've listed out the 6 trig functions and you got this for the 6 trig functions. If you got something wrong, go ahead and correct your work And make sure you ask questions at the start of class tomorrow. The next type of problem is going to give us one trig function, and we're going to have to use that information to find a different trig function. So as with all of these problems today, we're going to start out by drawing a right triangle. This time, instead of having the letter theta, we're going to use the letter A since the problem refers to angle A. Cosine of angle A is 4/7, so I'm going to go ahead and label my triangle like this. Cosine's adjacent over hypotenuse, therefore I label the adjacent side 4 and the hypotenuse 7. So how do we find the third side of a right triangle? We need to use Pythagorean theorem to do so. So when we use Pythagorean theorem, I'm going to go ahead and label that third side x for now, so I can set up my Pythagorean theorem. 4 squared plus x squared equals 7 squared. Once I solve the Pythagorean theorem, I get x to be the square root of 33. Now that I know that that third side is the square root of 33, I can go ahead and erase that x and rewrite it as the square root of 33. Now that I have all three sides, I can go ahead and answer the question that's being asked. Sine of A. Sine is opposite over hypotenuse. In this case, the opposite is the square root of 33, and the hypotenuse is 7. So our final answer here is sine of A is the square root of 33 over 7. So go ahead and try problem 4. Make sure you start out by drawing a right triangle, label it, and find the third side before answering the question that's being asked. So go ahead and pause the video now and try problem number 4. Okay, let's see how you did. Did you draw your triangle like this? Did you do the Pythagorean theorem like this? Once you get x, it's pretty easy. Cosine of A is simply adjacent over hypotenuse, which in this case is 20 over 29. Go ahead and correct your work if you need to. And again, if you have any questions, make sure to ask tomorrow in class. Next set of problems. The directions say find the exact value of the 6 trigonometric functions of theta if the terminal side of theta in standard position contains the given point. Now there's a lot of new vocabulary words here that we're going to talk about as the unit moves on, but the one I'd like to talk about right now is the terminal side of theta. An angle has two sides, a start and an end, and all this means is terminal side is the ending side. So problem number 5 states that the point 2, 1 is on the ending side of our triangle, of our angle, so we're going to have to go ahead and draw this picture. 2, 1 is in quadrant 1, so we're going to want to start by drawing the coordinate plane and drawing a triangle in quadrant 1. The angle, the theta, always is made with the horizontal, so it's always in the corner by the origin. Now we can next label our sides, and we label it like this. We know that the point 2, 1 is right here, so we go 2 units to the right and 1 unit up. Therefore, we label the triangle just like this. Now, just like in the problems previous, we have an unknown side, and we're going to use the Pythagorean theorem to go ahead and solve for that missing side. Pythagorean theorem will tell us that x is the square root of 5, so I can go ahead and replace that x on my triangle with the square root of 5. Now that I have my triangle, I can go ahead and list out my 6 trig functions. Sine of theta is 1 over the square root of 5. Cosine, 2 over the square root of 5. Tangent, 1 over 2. Okay, and again, these are the SOHCAHTOA functions, the ones that we used in geometry. Now the reciprocal functions. Cosecant, root 5 over 1. Secant, root 5 over 2. And cotangent is 2 over 1. Now it's your turn. Go ahead and pause the video and try problem number 6. Go ahead and pause the video now. Okay, let's see how you did. Notice 4, 3 is in quadrant 4, so notice how I have my triangle drawn here. And remember the 4 and the negative 3. Again, because you go right 4, down 3. Pythagorean theorem will get you the hypotenuse, and then there are your 6 trig functions. Correct your work if you need to, and go ahead and write down any questions that you may have for class tomorrow. Okay, now it's time for the last type of problem. This is where you're going to be given a trig function in a quadrant. The quadrant tells us how to draw our triangle. So in this case, quadrant 2, we draw a triangle in quadrant 2 with theta being in the corner by the origin. Next, we label our triangle. Tangent is opposite over adjacent. So I know that opposite needs to be 1 and the adjacent needs to be 5. I put the negative sign on the 5 because negatives in the second quadrant the x values are negative in the second quadrant, but the y values are positive. Now that we have this, the rest of the problems look exactly like they did in the section before. We need to find x using the Pythagorean theorem. Once we use the Pythagorean theorem, x is the square root of 26. Replace the square root of 26 on x, on the hypotenuse, and then we go ahead and we list out the 6 trig functions. One thing to make note of here, the hypotenuse, no matter what quadrant you are in, will always be positive. So if you ever do the Pythagorean theorem and you get a negative hypotenuse, you made a mistake somewhere and you may want to go back and check your work. So now it's time to list the 6 trig functions. Sine of theta, 1 over the square root of 26. Cosine, negative 5 over the square root of 26. Tangent, 1 over negative 5. Now the reciprocal functions. Cosecant theta, root 26 over 1. Secant, root 26 over negative 5. And cotangent, negative 5 over 1. So one more problem for you guys to try. Go ahead and pause the video and try problem 8. So pause the video now. Okay, let's see how you did. Here we go. Quadrant 4, notice how our triangle's drawn. This time we're finding the horizontal side here instead of the hypotenuse, but you guys are really good with the Pythagorean theorem, so I'm confident in your abilities here. If you have any mistakes here, go ahead and correct your work. And one more time, make sure you write down your questions that you have. That's it for today's video. Please make sure you have your book in class tomorrow, as your classwork will come from that, and that you wrote down any questions that you may have. Thanks, guys. See you tomorrow.